Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings, and tonight we're going to be looking at object-oriented programming in Python. Now this meetup group, Beginners Python and Machine Learning, we do a mixture of online and in-person sessions. Our next in-person session will be on 21st of February, and we look at topics to do with Python, getting started in Python, sometimes even a few more advanced topics in Python, and also machine learning. Now tonight I'm going to be looking at object-oriented programming, which Python lets you write programs that are not object-oriented, or you can write them object-oriented as well. Other program languages like Java, they make sure everything you do is object-oriented. And sometimes when I'm programming in Python, I forget that object-oriented is an option in my Python programming, and certainly for bigger programs, and when I'm working with other people on the project, then it does make your code a lot clearer if you can write it in an object-oriented way. So let's have a look. Today we'll be using Google Colab, and I've given you a link to a notebook here that you can use to follow along and do the exercises yourself. And you can even, for those who are watching live, you can ask questions on our Slack channel, Learning to Code, and which is in Beginners Python. And I'll also be listening to the YouTube chat, although I tend to miss that. But if someone sees the message come up on YouTube chat and you're on Slack, please let me know so that I can check it out. All right, so the first thing you should do, and remember you can ask any sorts of questions, even absolute beginners who get lost going, where's the link? So here's a link to a Google Colab, and I'm on the meetup site, but the link should also be below your YouTube video that you're currently watching. That'll take you to Google Colab. So open this up in a new window so you can watch the video and work in Google Colab at the same time. And the first thing that you should do is copy this to your own Google Drive, and that way you'll be able to make changes and save your changes. So I'll do that as well. So I'm using a different account here to the one that I used when I created it. And I will share this new one as well with you so that you can see any changes that I might make in this one as opposed to the original. So anyone with the link can view this. I'll copy the link and I'll share it on Slack. And I'll try to share it on the YouTube chat, but they often will hide any URLs I put in there and censor them. Okay, so this is Google Colab. Colab uses Jupyter Notebooks. You can see that this file is an IPYNB, which is a Jupyter Notebook file. And they're made up of a bunch of cells, which can be either text or code. This is a code cell, this is a text cell. And you see if I hover in between them, I can add another code cell or another text cell in there. It's a really good way of getting to know Python, because you can run just a couple of lines of code and see the results immediately. So the first thing we do, we click on connect, although it will connect automatically if you don't do that. And Google will set up a virtual machine for us to use, and each person gets their own one, so it's just a little Ubuntu server that you'll be playing with. And then we can start. So you can see they've given us some RAM and some drive space. Okay, now I've given you some links up here to the YouTube. This is our GitHub site, which got all the past sessions in it. And and you can look at those past sessions to get the YouTube links as well for any videos that are linked to them, and you can even look at the meetup site if there's any information there. giving you a couple of references here. If you want to learn more about classes, you can look up there. Okay, so to run a code cell, you can see it's got this play button in the code cell. So you just click on that and it will run the cell. Now this first cell I've got is just importing a few built-in libraries so that we can use them later on. So that doesn't actually do anything very exciting. So we'll move on to the next one. And so the next one, we're just going to have a look at complex numbers. Now, complex numbers are a built-in feature of Python, often forgotten, but it's proves to be a good example for this case. So let's run the cell. The way you create a complex number is you use this special character j with a number in front of it, so 3 plus 4j, and j basically stands for the square root of -1, which gives it an imaginary part. You know that you can't take the square root of a negative number, but complex numbers do have a use in mathematics. So now we've stored 3 plus 4j into our variable c, and we've tried to print it out. And I've just used f strings here. If you don't understand f strings, let me know. But it's a nice way of printing out things. So I can print out what the value of c is. So c is 3 plus 4j. I can print out what the type of c is, and it's a class of type complex. And I can print the representation of c, which is just another way of looking at it more from a programming point of view, how it's represented. But in this case, it's actually represented very similarly to how it displays. All right. So selling C is an instance of class complex, and we can actually there's a built-in method isInstance in Python that will check any object and tell you what class it's in. So these are objects. This is what we're talking about, object-oriented programming. But these are built-in objects, so you can use them straight off. In fact, every data type in Python is an object, and so it's been written in an object-oriented sort of way. You're free to then write your whole program in an object-oriented way, or you can just use them as variables. And what makes an object is that you store data in the object, and in the form of attributes, and you can also run functions on that object, and they're called methods. So let's run this cell, and it's telling us C is an instance of complex. That's true. So that's one way of finding out what class or what type of object you've got. Remember, the other way we tried up here was using the type function, and later on I'll tell you what the difference between those two functions are. Okay, so we can find the values of attributes of objects by using this dot notation. So c.real will tell us what the real value of the real attribute in the complex number is, and that's 3, which is this number here, 3. And c.imaginary will tell us what the value which comes in front of the j is, and in this case it's 4. So let's run that cell, and that'll print it out. c.real equals 3, c.imaginary equals 4. Okay, so that's looking at the attributes of an object. And now the other thing I said, which is you can run a method of an object, and one of the methods that complex objects have is conjugate. So for any complex number, I can easily find what the conjugate is by calling c.conjugate, and it will tell me. So remember, our value of c is 3 plus 4j, and if we want to know what the conjugate of 3 plus 4j is, it's 3 minus 4j. All right, now at this time you can throw in an extra code cell if you want, and maybe do something like I equals 3, and then you want to say tell me what the type of I is, and it's an int. So that's another object. it's not as interesting as complex, so that's why I'm using complex now, but I could have used int for this example. Okay, so when you're instantiating an object of a non-built-in type, you would use the class name and some arguments. So the class name and then parentheses and arguments to create that that object. And in fact, we can do that in we can do that with the built-in types as well. It's easier to say I equals 3 rather than I equals int 3. But I equals int 3 will do the same thing. So in the case of complex, we can say C2 equals complex 3, 4 rather than saying C equals 3 plus 4j, and that will give us something very similar. So here we've got C, which we just said was 3 plus 4j, C2, which we've instantiated or created by using this form of the class name, and that's also 3 plus 4j, and we can even do do a test to see whether C equals C2, and that is true. Okay. Alright, so how to define a simple class. Now when you are coming up with class names, the convention is to use title case for class names. So that's pretty much the same as Java. So here's an example, my class name. It's 3 words, and we've used capitals for the beginning of each word and then just concatenated them all together to make the class name. And here's another one, my simple class. So let's run this, and now we've created a class called my simple class. Now we can create an instance of that class, which is just an object which is of that type, and that's going to go into a variable name. And remember, in Python the convention for variable names is to have your words separated by underscores and have all the words in lowercase, and that just makes it a bit easier when you're looking through your code to work out which is your class names and which is your variable names. Okay, so I've just created a variable called MSC instance. It's going to be of type my simple class. So, if I said, tell me what the type of MSC instance is, it's going to say it's of class my simple class, and it's actually in the module main. Now we can add attributes to it, and they can be set on instances of the class just by doing this, just by putting a dot on the variable name and say dot a equals, and we'll give it I'll just give it a string called value a, and that just saves that string into the class. So you can just keep adding new attributes as you like. It's best when you're defining your class to say what those attributes are going to be, so that it's sort of like a documentation, so that when people are using your objects, they know what attributes they're likely to come across, rather than just creating them willy-nilly through your program. But it is possible if you need to do that. Okay, if you want to read the value of that attribute later, you just use the dot notation as well. So the representation of MSC instance.a is value a, and because I've put an exclamation mark R there in my F string, it's done the representation of the string rather than just the value of the string. If I hadn't put the exclamation mark R there, it wouldn't have added the quotes around it. Okay, so we could define our own class called complex, which has some of the same properties and behaviors of the built-in class complex. So we use class and then our class name, so it's just complex, and then we add methods into it. So methods that we're going to add into it, if you create an init method with double underscores before and after the word init, and that's got a special meaning, and that's what's called when you instantiate an object using the class name and parentheses and then the arguments. So takes in there the parameters, real and imaginary, and they get assigned into the object. Now classes do this, the way that Python's implemented object-oriented programming is that any method that's in a class like this, if the first argument that comes in will actually be, it'll substitute in the object itself. So you can call it anything you like, but I really strongly recommend you use the word self, because everyone else in the world uses self, and they're going to be able to understand your code when they try to read it. So self is the object. We're saying self.real equals real. So this is the attribute of the object, and that's the argument that's been passed in. So we've used the same names. You don't have to use the same names, but we've assigned it to the attributes. And so defining all your attributes in your init's a really good idea, rather than just having them created at random through your code. And self.imaginary will go into there. Now we'll create a method. I'll go to this one next, conjugate, which will create a new complex object and return it, which is the conjugate of our original one, and basically it's got the same real number and the negative of the imaginary number, and that's the conjugate. And now this third method we've created here is one of the double underscore methods, and so it also has a special behavior in Python. So if anyone ever tries to print your object, it will look for a method called dunderString, dunderstr, and then it will display it. And it's surprisingly difficult to do this in one line, how to display a complex number, because we actually want to show the real and the imaginary values. But if the imaginary value is negative, it'll automatically put a minus sign. If it's positive, it won't automatically do a plus sign. So we have to put some code in there to say if it's greater than or equal to 0, we actually want the plus, and then self.imaginary and j. So let's run this cell so that we've defined our class, and it doesn't actually output anything, it's just defined it for us. But now we can do things on it, so we can create objects of this class. So this is d equals complex. Remember this one, our class, it starts with a capital C. The built-in one starts with a lowercase c. So we can create a new object, and we can find out what its conjugate is. So 5 plus 12j is 5 minus 12j. So you can see the behavior is sort of similar to the built-in class, and that's just how we've created it, using this object-oriented method of creating a place to store some data and have methods that define how it behaves. If you want to find out what all the attributes are of an object, you can look at its dictionary. So it's saying the attributes of D. So this is a built-in property of the object that Python adds to the object that we created, and as you can see, it's got real and imaginary. Another way of doing things is you can use the built-in function dir, and that tells you all of these things. So these are all methods that will have some default value in Python, and these are the ones that we've created. So we've created those ones: conjugate as a method, image and real as our attributes, and we've also created a string and init. So they're the ones we've done, and other ones have been put in by Python automatically. Okay, so we can also look at attributes of the class itself, and that will show the methods. So they're the methods that have been defined explicitly. The others were just showing what could be called by defaults. So because they've been defined with the class, they're on the class itself, not of the objects that are of type that class. Okay, now I've set a task here and I've given you a blank cell to work on, so you can either pause the video and have a go at this, or you can just follow along with me and then have a go later with it. And I've given a full solution down below as well, so you don't even need to type anything if you want to just watch. But I'll just do a simple way of doing it. So I want to create a class called invoice. So we use the keyword class, and we use our name invoice. Now we want it to take 3 parameters, so I'm going to define an init method, and when I open parentheses, then I have to put in the parameters. Now remember to put in self first, and then days terms and date document. Okay, another colon because I'm defining a function, and so I get indented again. If you're new to Python, Python defines code blocks by how far you're indented, rather than beginning and ending them with curly braces, as in Java or C. Okay, now we just want to save these values, and Google Colab is quite good at prompting what we've might need. Nothing there. Okay, that'll do. That's our class. So that satisfies what the task was asking. It'll just create new objects. It'll just store those 3 values into the object when that gets instantiated. Now I've provided a solution here which does a little bit more. Firstly, when I've added doc strings into all my code, and that's really useful because it's a sort of self documentation. If someone calls help on your class, it'll return the doc string. If they ask for help on any of the methods in the class, it'll return those doc strings. So the doc string is just the string that's the first thing that it comes to. It's not assigned to any value, but it's just placed there in the code. Then it's doing the assigning our values in. Now what's different here is we've provided some default values. So if the days terms is not provided by the person creating the object, then it'll automatically default to 30 days. If the date of the document is not provided, it'll come in as none, and then when we're creating date of document as an attribute, we'll check to see if it's none. If it's none, we'll just put in today's date. Otherwise, we'll put in the date of the document that was provided. We've added an extra method here, date due, with self, so it just looks at the date of the document and adds in the days of the terms, and that'll tell us when our invoice is due. So that means we can create an invoice with just 1 parameter, even though it's looking for 3, and it will automatically put 30 days terms on it based on today's date. So let's run this and see what we get. We get an invoice for $350 dated today's date, and it's due on the 23rd of February 2024. Okay. So when we are calling a method like date due, we can call it like this, iv.datedue. In fact, that's just the text. This is where we're calling it, iv.datedue. So it's the object name, a dot, and then the name of the function, and then parentheses. And when that gets called, it'll actually put the iv that's there into the first parameter in here, which is called self, and so it'll be iv.dateDocument plus blah blah iv.dateTerms. Now you can actually, because they're just standard Python functions, you could call it on the class itself. So it's part of the class invoice. I'll better do this one here. And so we could call that function, and we say self, we want self to be iv. So there's two ways you can call it. Most people will use that way, but sometimes, you know, in rare circumstances, there might be a need for calling it this way, and so that's an option for you. So let's run that and just see that they both work and they both give the same answer. All right, add a string method to the class so it's easier to print the invoice. Okay, so normally what you would do, you would put that in the whole class definition. So I'm just going to copy and paste. And the name is double_string, or we say that we call that dunder string. And it's going to be take one parameter, which is self. You see Google Colab's automatically put in some type hinting there to say that it's going to return a string, which is true. And here we can just say return some string. So we'll use an F string. Invoice for dollars self.aud amount due self.date due. Okay, let's create a variable with that value. Let's call it $300, and then we'll print it. So if I just say print IV, there we go. It just prints. When it sees print IV, it knows to look for double_string and do whatever that method is, and that returns a string like that, which when we print it looks like this. Okay, so let's look at the solution. The solution creates a function called string invoice, and the reason I've done that here is because we're not actually in the class at the moment, so this is just a function. I've used the variable name self as my parameter, and I've done it with some nice formatting, so it gives me 2 decimal places, and it formats the date with a day, month, year, and so that's when it was created and when it's going to be due. And then I can assign that as the function double_string just using this command, just like we did attributes before. You wouldn't normally do it this way, but we're doing it in Colab because the other code that we've run, the previous cells, has already been run, and rather than having to copy and paste the entire invoice definition like I did here, I can just change one function in it by assigning it using this attribute notation. So if I run that, you can see here now it looks a lot nicer. I've got $300.00. I've got the date of the document, which is the 24th of January, and the due date. And those date formats look a lot nicer. You can even do this all in one line just using Python's lambda function. It's probably a bit off topic, so I won't spend a lot of time on that. Okay, create a class for quote, which has values for amount, days valid, date quote, and method date valid too. Okay, well, I'm a big fan of copy and paste. although if you're doing it too much in your code and not changing stuff, then there's a possibly a way that you can do it better. So you shouldn't really repeat yourself in code. And in fact, this is a case of that too. But I'll do it the copy and paste way first, and then we'll look at the solution. So we're going to create a class called quote. I'll get rid of the docstring because that's wrong. So the quote constructor has values for amount, days valid, date quote, and a method date valid too. Okay, so we'll store in here the days valid, and we'll have a date quote which will default to today, but otherwise it'll use the provided quote date. Date valid 2. Alright, and let's do a test. Q equals quote 250, and I'll just use Google Colab Q. Okay, it's done that. Well, let's do print of that, and really I should change the string there. Quote for $250 due on the 23rd of, actually I shouldn't say due, it's valid too. Quote for $250, valid to the 23rd of February. Okay, so that's your copy and paste way of doing it. Let's have a look at the solution. This uses inheritance, so it's starting again from scratch. So we'll create a thing now called a document, and it does all this stuff. It takes in an amount, duration, a date. It's even got this thing called action and a document type, and stores all them in the class, and then it calculates this date, which is basically whatever the document date is plus some number of days, and it's got a fancy string way of displaying, and the string actually uses this doc type. So we've added an extra attribute here, doc type, so we know whether it's going to be a quote or an invoice. And then once we've got that, then we can just create invoice, which inherits everything from document, except it creates this date due method, and it just calls date duration from document. So that makes it a lot simpler. And similarly for quote, date valid 2 is just using date duration from the document. So because we've used parentheses here with a base class, then this class here will inherit all of the methods and attributes of the base class, and then we can add any extra behavior that we want to it. So now let's create a quote called 346, and let's have a look at what it looks like when we print it. So let's run this. So it says quote for 346, and you can see we're passing in the quote there. The action, so we've had to pass in an action too, so it's going to be valid until, while the action for invoices is payment due, and then we've got the 3 amounts that got passed into us. We've got a different default value for days valid. It's valid for 14 days, while the terms for invoices are 30 days. So you can see, if you've got a lot of documents of this sort, you can save a lot of typing, and really whenever you're doing copy and paste of large bits of code, then you ask yourself, is there a better way of doing this? And the reason is because sometime in the future you might want to change it, and if you've got copied code that you then work out there's a better way to do it, you've got to find everywhere you've copied that code to and fix it. And then when you're doing that, you might miss one, and so you got all this copy code everywhere where it works in most places, but you've forgot to fix one of them, and so it doesn't work, and trying to find that can be quite difficult. So it's but if you fix it here when it's all used inheritance and you've just copied it once, you've just got one copy of it, then it will you fixed it for anything that uses it. Okay, task 4, create a sales order class which has days deliver when goods need to be delivered. Okay, so I'll copy and paste just as a template, even I told you not to copy and paste, but we'll be changing most of it here. So let's call our class sales order. It's going to take in an amount, days valid. In fact, we're going to have days deliver. Let's default that to 7 days. And the document date can also default to the today's date. So it's going to be a sales order, deliver, and we're going to deliver it by 7 days or whatever is specified, and we'll have a special method in our sales order which we will call deliver by. That will just look at this date duration. Okay, so let's create a sales order for $123 and print it. Days valid is not defined. Very good. And there we go, a sales order for $123 dated 24th of January, delivered by the 31st of January. Okay, and here's the solution. Solution looks pretty similar to mine. It's just been doing the doc strings a bit more diligently than I have. So how are you going? Are you managing to do these exercises as we go through? Task 5, create a class item which can represent a line item on a quote, sales order, or invoice. Needs a description, quantity, and unit price. So you should be getting quite good at creating classes now. We use class keyword. We create the name of the class, and then we need a constructor way that the class can be created, and it's just got to catch the 3 pieces of information, and so it's always called init. And if we call it init, then we can use just that notation of in this case item and parentheses and the 3 values. So we'll have description, quantity, and unit price, and we'll just store them. Okay, so that's created the object. And I can see what I've done wrong. I've got some warnings there under the myself, and that's because I forgot to put in self as one of the parameters. And I run that, and it's created it. So let's have a look at the solution. Solution's done a little bit more. So in the solution, it's add a method to give me the sell price in Australian dollars. So it'll take the unit sell price, multiply it by the quantity to get the extended sell price. And it's added a string, which is always a great thing to add in because then it makes it really easy to print stuff out. The string title is a class attribute. Where's string title? Oh, here we go. So we're defining that. So that's fine to use, but don't use mutable values in as class attributes. Okay, and the reason we're creating this title is it's going to be the same, and it allows us to print a title. So let's run this and see what it looks like. Well, that's created it, and now if we create a couple of items and then print them, you can see we can print out the title, item.string title, and that's fixed. Like there's nothing in there that's going to change with time. We've just said, we've got 20 characters for description, 5 characters aligned right for quantity, 10 characters aligned right for unit price, and 10 characters aligned right for price. And this is what that looks like. So that's quite a nice format. That's quite easy to produce. So task 6, create a report in document for all documents. Okay, so I might just go through the solution that's provided here. We'll create a function, and it's just based on self. And so this function we're going to put into the document class as we do down here, and it's going to be in the document class. It's going to be called report, but out here we're just calling it document report, and so it'll just run with self. So it's going to look at the amount on the that's the amount of the document. So remember that was the invoice amount or the quote amount. It's going to pull up the date. It's going to have some finish date, which is going to be formatted in the date format that is fixed in that class, and it's going to print out some nice headings, and then we're going to add in our titles. So we've got our each item is going to have a string title, and we're going to in our document we've got a list of items. Where did we put them in? Oh, here we go. Yeah, so document add item. So this is a way of adding items into our document, and then we've modified our class. Here we are modifying the class on the fly. So this is not what you would normally do, and in fact I've put the full final definitions of the class at the end of this notebook, so you can see how you would normally code it if you weren't using a Jupyter Notebook. So we've added that function in. The function's called document add item here, which is that thing there, and we've assigned it to class document to look at list items. So now that it's in list items, we can loop through those items and print them out, and we store all this into a method that gives us a quick report that we can run. So let's have a look what that looks like. So we've got a quote heading here, it's got a date, it's got how long it's valid to, it's got a list of all the items, other charges, and a total. Okay, so remember before we were looking at is instance to see if something was an instance of a class. Well, it's actually, if something's an instance of a subclass, it'll actually also be an instance of the superclass. So in this case, document is the superclass, and all the subclasses are quote, sales order, and invoice. So we've got a few objects that we've created. We've got a quote, a sales order, and an invoice. So we'll just loop through those, each time putting it into variable D. We'll print it out, and then we'll check whether it's an instance of document, of quote, of sales order, or invoice. So let's run this and see what it looks like. Should be a fair amount of printout. SO is not defined, and that I must have forgotten to run. Here we go. I didn't run this cell, so if I run the solution for, now we've created our sales order. And I can go back down here and run this one. Okay, we've got a quote for $346. That's a quote is our document. It's a quote. It's not a sales order, and it's not an invoice. So this is more useful than type was before, because type would only tell us if it's exactly the right type. It wouldn't identify subclasses as being of that type. So quote and sales order are of type document. Invoice is not of in fact, invoice, our IV is not of the type invoice that is a subclass of document. It's of another class of invoice. So it's telling us it's not a document, and it's not of the type, this new invoice that we've created. There's a bit of a problem because we've been defining invoices in two different places. So we defined one invoice, we created an object of that type, then we defined it again. The object is still of the original definition, so it doesn't qualify for isInstance. Now we can create another invoice. So what are we doing here? We're doing an example of adding items to an invoice using that method that we've put in there, and then printing out a report. So it looks pretty similar to the quote report we checked before. So we're getting a lot of functionality for free, because we've just added that to the document class, and then all the subclasses are getting that functionality. Okay, task 7, add a method to invoice so users can check the value of days terms without having to know the subclass name days duration. Alright, so we have to define a function. So let's call it invoice days terms. And it's going to return days duration, because we don't know that name or what it means. And then we can add that into the class. Like that. And then we can, let's just have a look at invoice2.days terms. So there we go. We've created a function. We've assigned it into the class, and like I said before, normally you would do this at the time you're defining the class. And then we can call that method on any objects of that class. So IV2, we can call it, and it's returned 30, which is just by looking up days duration, which is what it's stored as internally. Now let's have a look at the solution. So the solution's doing it a different way. Well, it's done pretty similar. So it's created a function here, which returns the days duration. It's assigned that into the invoice, but the other thing it's done is it's used this decorator. So a decorator is anything with a @ symbol in front of it, which modifies the behavior of the functions. And what the behavior has done here is it made it look like an attribute. It's actually what we're calling a property. So we can refer to it in the same way we would refer to attributes. So now, rather than saying iv2.days terms and have parentheses on it to get the value, we can just say .days terms, and it will call this function even though we've only called it like an attribute. And the big advantage of this is that you can define your class to be using attributes, and if later you want to change the way the class is defined, but you don't want people to have to change all their code that is referring to these attributes, we can just put in a property on a function, and their code can all stay the same that's used these attributes, and then they but it will call the behavior of the function. And this reduces so much code compared to a lot of Java coding I've done, where we've always thought everything that we've got in our classes, we thought sometime in the future we're going to want to make it a function. So we've had to define everything as functions right from day one, so that people would be referring it to by the function. So if then we wanted to change the behavior, we could just change the function, and we basically made all the attributes, we made them private so that people couldn't see them directly. They had to go through the functions. But there was a lot of boilerplate code being generated that way. This way we only have to define the functions when there's actually something in the behavior, and the person who's using the class doesn't even have to know whether they're calling a function or an attribute. So the problem with this solves the getter, but it doesn't solve the setter. So if I try to assign a value to days terms now, it goes, you can't set that attribute, because we've only defined what to do in the case of looking at it. We haven't defined what to do if you want to set it. So let's have a look at task 8, make days valid a property for quote. Okay, so this is pretty similar to what we've just done. We use the at property decorator. We define our function the function of self, and it'll be the same thing actually. Return self.days duration. And then we assign it into the class. And then we can just call it and have a look at what the value is. And there we go, 14. So let's have a look at the solution. So this time in the solution, we've created two functions, both with the same name, and we've put a decorator on the second one to say, well, the first one's a property, and then the second one we use that name of the property, which is days valid, and we use .setter. And we can only do that if it's been defined as a property up here. And it's saying if someone decides to set the days valid using this attribute, then they're allowed to do it, and it will store the value into days duration. So that gets around your getters and your setters in Java that you've been having to write. Yeah, so this is one of the things I like about Python. Okay, so that's most of what you need to know about classes. This next topic is talking about variable name with underscores. It's a pretty advanced topic, and there's probably only one bit I use, which is the one underscore to create a private variable. So the convention in Python, if you've just got a straight variable name that doesn't start with any underscores, that's a public variable accessible as an attribute. If you start it with one underscore, then you're pretty much telling anyone who's looking at your class, don't try looking at this private variable. Like, there's nothing to stop them looking at it, but you as the writer of that class recommend that they don't, because you might change something integral to its behavior in the future or take it out, and so if they're relying on it, then their program will break. Then there's another one, two underscores, which is called a subclass accessible private variable, and this is actually like the one underscore. Python doesn't actually do anything about it, it's just letting you use the one underscore. But as soon as you put two underscores there, Python does some name mangling, and the reason it does that is when you've got lots of subclasses and you want to be able to refer to a particular variable in a superclass or in the superclass of the superclass, and how do you refer to it if it's just got the same name as a variable in your class? Well, by using the double underscores, then Python will change the name how it uses it. So if you need to refer to it, even though it's a private variable, if you need to refer to it, you can use the name that Python has mangled. So let's have a look at an example. So I've got a class called my base class. Here are some class variables. So these ones will just stay the same for the class. So anything in that class will have those variables. Now, when I initialize an object of that class, I'm not going to change the ones, but the twos and the threes, which I'm going to create from scratch, the twos are going to overwrite the values of the twos in the class, so they'll just become instance variables rather than class variables. And the threes will only be instance variables, and there's no class variables there. So you can see I've used names: class variable, class variable, class variable, and here I've got instance variable, instance variable, instance variable, so that I can keep track of what's going on. And then I've got some methods so that I can refer to it from within my class by calling this, what's the dunder, so double underscore 1, double underscore 2, double underscore 3, and I've created this new word sunder, being single underscore 2 if I want to look at it. Okay, so I create a class of an object of that class, and I'll have a look at the values. So let's run this and see what we get out. So my 1 is a class variable, my 2 assigned as a class variable and an instance variable, and my 3 assigned as an instance variable with a reversed string parameter. Oh, they're just headings, yep. And now I'm just going to see what they come up with. So my ins.my1, that's a class variable. My base.my1. So I can refer to it either through the object or the class name. I still get the same value. Same with the single underscore value of those, and they're both a private one. Now if I try to do it on the double underscore of my1, it says my base object has no attribute my1, even though, you know, we created one there. Double underscore my1, why isn't it seeing it? It's not seeing it from the object, and it's not seeing it from the class. Has no attribute, has no attribute. However, if I look for my_ins dot single underscore my base double underscore my1, it now gives me a value that it was created with, which is this class variable. So that's showing how I have to refer to it now if I need to refer to it outside of the class that it's in. And similarly, so there we got the 2, we got our remember this one we overwrote my 2 in the instance, we didn't overwrite 1, so now my 2 is an instance. When it's my instance, my 2 gives me an instance variable, but I can still refer to my base, my 2, which gives me the class variable. Instance class, once again no attribute, but I can use this name mangling. And then we go to my base, my 3. So this one wasn't created in the class, so it has no attribute in the class, but it does have an instance variable. Same with the single instance. Double underscore, as we might guess, no attribute, but when we looked at the mangled name, it does work and does return. In fact, this has got BPAML backwards. But when I call it by a method, I can just use the unmangled names, because when we created those methods it used the unmangled names. So Python itself worked out to know where to get those ones from. And I can create a subclass, and that shows how I can refer to something up the line. So subclasses can be pretty similar. For 2 and 3 we're going to save variables, and let's run it and see the output, because it's all pretty complicated to see there. So when I look at my base, so double underscore my1, once again no attribute as you'd expect, and then in my subclass instance I've got I can refer to my base my1, so I can look straight at the superclass value of my1, or I can look at the subclass value of my1. And similarly, when we get to my2, how does it handle when we've got instance variables as well as class variables? Looking at the mangled ones, we've got so my SI is an instance variable, but I can refer to the instance variable version of the superclass, and so that's instance variable subclass. But I can, if I use the class of my sub, and then I can refer to the class variable of the superclass. Okay, that's pretty complicated. I'd recommend you just go through it yourself. If you need to be able to refer to in attributes in a superclass that's got the same name as attributes in your subclass. So finally, one last topic I'll quickly mention, where Python is different to other object-oriented programming, is that it allows object-oriented programming languages, is that Python allows multiple inheritance. So when you say which your superclass is going to be, then you can just put both classes in here, and it will inherit from both of them. And it has this thing called the method resolution order, and that was that just tells you which way it's going to, if it needs to find a method, how it's going to look for them. And it's going to look in my complex sub first, which is the class we've just defined. Then it's going to look in complex, which is what it's inherited from, and then it's going to look in my base, which is what it's also inherited from, and then it's going to look in object, because that's what these ones have inherited from. So once you know that method resolution order, then you'll have you'll be able to work out exactly what the behavior is going to be from a programming point of view. And we showed that we can get both bits of value. So we can create a complex number because it's uses complex, and then it we can also get these my1, my2, my3 properties that we've got out of my base. We also, and this shows you how to call the multiple superclasses. So that calls so I think that's going to call my base, and then this one is going to call the complex version of the init. So that they both inits get called. Okay, and here I've just given you a bit of an example how to design base classes to make use in multiple inheritance easier, and that's you make sure you capture all the keyword arguments. So if you're familiar with this notation, if you use that in your base 0, then whenever you one of your subclasses is initiated, you look for key 1, but you also capture all the other keyword arguments that have been provided, store them in that, and then you can send them to the init of your superclass. You lose the self-documentation that having all the variable names listed out nicely gives you, but it does solve the other problem of having to know all the all the keywords that could be passed to your superclasses. And then last thing, I've just given you the full class definitions, including docstrings for document and invoice and quote. So that's how you would normally create them, rather than that step-by-step that we did during this notebook. So I hope you've learned something from that. I didn't get any comments during the show, so there's nothing there to answer. Next week, Arun will be doing a session on machine learning, and then the week after that, I'll be doing a session for absolute beginners, so it'll just be going back to someone who's never seen Python before. We normally do that on the first Wednesday of the month, and so that's, if you've got questions, then well, I mean, you could ask them today, but if you've got questions as an absolute beginner, don't feel afraid to ask them at our absolute beginner session in a couple of weeks. And then I look forward to seeing you all on February 21st at our in-person session in Brisbane Business Hub in the Queen Street Mall. Okay, thanks.